Hello again, it's Randy, and we are going to solve another machine problem. So this time we're going to be dealing with eigenvalues, and for MATLAB we're going to be using the eig function, which gives us two values, the eigenvectors and the eigenvalues. So let's see the problem. So this LC circuit can be modeled by the following system of differential equations, where the LC circuit looks like this, and then we have the following systems of differential equations as follows, where L sub j is the inductance H of each inductor that runs from 1 to 3. I sub k is the current A in each identified loop that runs from 1 to 3. C sub L is the capacitance F of each capacitor that runs from 1 to 3. And T is the time in seconds. So if we assume that the solution that follows the form I sub k is equal to I sub k multiplied to sine omega t, determine the eigenvalues omega sub k and eigenvectors I sub k for this system that runs from 1 to 3, and let L1, L2, and L3 be equal to 1h and C1, C2, C3 to 0.25 f. And we're going to display our results in the command window. Okay, so first things first, we want to make this look like a matrix where we can solve it in the form of an eigenvalue equation. So first off, we're gonna fix this systems of equations. So let's go to OneNote, and I'll just run you through. I'm not gonna explain the whole thing because it's long, but hopefully you can understand it, and I'm gonna put my solution in the description. Okay, so for convenience sake, I converted our OneNote file into a PDF file instead, and then here's our equations, and of course we differentiated I twice, so we get negative I omega squared sine of omega t, and then we substituted the values, and then we finally get this for our first system of equation. So for our second system of equation, of course we substitute the values again. We change the subscripts because we have uh, different values for each of these variables. So this is our second system of equation, and then this is our third system of equation, which will eventually look like, if you arrange this, all these three equations, it will look like this in this form. So now it looks like a matrix, and then if we remove omega squared from there, we're gonna have this, which is actually in the form of our eigenvalue equation. So this is our matrix A, and this is our lambda, and this is our identity vector, and of course this is our matrix x or whatever variable you want. Okay, so now that we have those values, we're gonna solve it using MATLAB using the eig function. So as I said, it gives us the eigenvalues and the eigenvectors of our given matrix. So we're gonna clear this first, just in case we have previous variables from any previous MATLAB uh, scripts. Then we're gonna have our constants. So L1 is equal to 1, L2 is equal to L1, L3 is equal to L2. We're gonna omit that. For C1, 0.25. Same case with this one. They're all equal. Right, we're gonna omit that also. And then we are gonna define our vector A. So we have A equal. Alright, so let's look at that first. Okay, so now that we've defined our eigenvector A, we can now look for the eigenvalues and eigenvectors for it. So since we do have two outputs that are gonna come out, we're gonna have two variables. So V would be our eigenvector and O would be our eigenvalue. Now we're gonna use our MATLAB function eig of A. We're gonna run that, And then there you go. So these are our eigenvalues, and these are our eigenvectors. Okay, so now since we have all our values available now, we are going to display them on the command window. So let's do that. So we're going to have, okay, we're going to run that to see how it looks. Okay, let's put a space there. Then we're going to do the same for the eigenvectors. I'm just going to replace this with V, V, and V. There you go. So we are going to run that, and there you go. So I think we've already solved this machine problem. Hopefully I didn't do anything wrong. If I had any mistakes during my systems of equations, how I solved that, please feel free to correct me. And that's all for this problem. Thanks for watching, and I'll see you in the next video.